Okay, hello and welcome all Design 2 students. Today's lecture is load and stress analysis. In this lecture, we look at load and how to calculate stresses and how to find different type of stresses. We start with the revision of what was covered in strength of material. I have few examples on how to calculate reactions. So the procedure is first identify load and the forces with their point of action, and then you calculate missing reactions or loads. Then you draw shear forces diagram and bending moment diagrams. So in this example, we have shear forces diagram and bending moment diagram based on the given loads. The purpose of this shear force diagram and bending moment diagram is to identify critical sections in any body or any machine element, in this case this beam. So for this beam, as you can see, this section, here we have shear force of 90, and there is also bending moment of 900. So at this section, this cross section of the beam has the maximum bending moment and also has shear force. Maximum bending moment and force will give you an indication that stress in this section will be the largest along the beam, which also means that this section is expected to be critical, this point. So any failure, if we increase load or if the material is weak, the failure will happen in this section. In other words, if you design your beam and you select your material and maybe also size to give you strength that are larger than stresses in this section, you can prevent failure. Okay, so let's go on. I have few examples just to refresh your memory and how to calculate missing forces or reactions, and then how to build shear forces diagram and bending moment diagram. Okay, the next example with distributed load. Okay, so stresses. So as I said, we have two main types of stresses: normal stresses and shear stresses. So normal stress is a stress coming out of the surface or going inwards to the surface. So when you cut, you will get a cross section. Let's say we have a beam and you cut the beam and this cross section. Any stress coming out of the cross section of the surface or even going towards the surface is normal stress, represented by this symbol, sigma. Normal stress is positive. If stress is tension or going out of the surface, we call it tension, and then it is positive. If it is going towards the surface, then it is compression and it is negative. The other type of stresses is shear stress. So if I have machine element like this is shear stress. Shear stress is tangent to the surface, in the surface itself, and it's represented by this symbol, tau. So now we will look at sources of normal stress and sources of shear stress. Okay, so for normal stress, we have two types, and for shear stress, we have two types. Two types of normal stress coming from forces and normal stress coming from bending moment. For shear stress, the same, we have shear stress coming from force and shear stress coming from torsion. Okay. Now, this is just the science for consistency and uniformity.